It is a trig function of beta alone.
Why does that do that? 70?
Well, do you understand the steps?
Yeah.
Okay, and then as far as if you're wanting to think graphically, this is a cosine function shifted left 90 degrees, which would look like a negative sine function.
So, how does he...
Okay, so you know how I got here? Or just know how I got here?
Yeah.
Okay, cosine of 90 is 0.
Yeah, but then how did you get to negative
0 times anything is
0?
okay, so this goes away.
Oh, that's cool. Isn't it minus 1? Alright.
We need to see a tangent, and those are a little different, little yucky on the simplifications. So we're going to work the tangent one. So I'm going to find the exact value of tangent at 7 pi over 12. So this is good review from yesterday with how to break up the 7/12. But then it'll be a little new on the simplification of tangent. So how am I going to break it up?
You're going to...
Good. 3 pi over 12 plus 4 pi over 12. Does everyone agree? That's a good choice. Okay. Why? You can make it anything you want. Why is this a good choice? Simplifies. It reduces, right? You want to do the easiest you can think of this. This one is probably the best choice for this. Now, the one we worked in class the other day had like 10 choices. This one's probably the best one. The only other option would be subtraction. Which you could do some kind of subtraction to get 7 pi over 12. So I'm going to reduce that to be tangent of pi over 4 plus pi over 3. And then what is the equation for tangent?
Over 1 minus 1 tangent over 4 plus... Oh, see.
I'm glad I did that. I'm not sure I gathered anything. I did several times. Yes. Any questions so far?
Yes.
Yes.
Can we do another?
Well, we're not done with this one yet. That's a good question. What is the tangent of pi over 4? 1. Does everyone agree that tangent of pi over 4 is 1?
Yes.
What is the tangent of pi over 3?
Square root of 3. Yes. How'd you know that?
Yes, and if you want to draw a quick picture, pi over 3 is a 60-degree angle, right? Which is a 1, 2, radical 3, the tangent's opposite over adjacent. So if you need to draw the triangle, draw it really quick, that's okay. 1 times radical 3.
Radical 3.
Radical 3. Now, this is an okay answer, but if we were matching multiple choice, they probably would rationalize it.
Right.
So how in the world would you rationalize something that...
5
Why 1 plus radical 3? Why would you choose 1 plus radical 3?
Because if you just choose radical 3, it just...
Because negative times a positive is negative.
It's kind of like a difference of perfect squares backwards. This is fun. So on the top, I do have to distribute that out. No, I'm growing. I'm working on it. First, outer, inner, and last. How in the world did I get 1 minus 3 on the top? The inner and outer cancel. 1 squared minus squared, which is 3. So I get 4 plus 2 radical 3 over negative 2, which simplifies again to negative 2 times the square root.
Good.
We get to see that one not because of the trig part, but because of the simplification in the algebra part. No, it's a little bit. Yes, I do want to see you simplify it more.
You gotta switch it.
Oh no, don't say that.
Well, see, in algebra 2, things really are. You know,
They're chicken.
but in trig and calculus, they get tough. So we want.
They get turkey.
Okay, so how do we find the exact value of tangent of 105?
You gotta
do it.
What are we going to split it up?
45.
30 and
I like 45 and 60. Does 45 and 60 work?
Yes.
Maybe. Maybe. I play football.
Okay.
Okay.
I didn't mean to make this way, but doesn't it turn out to be the exact same?
Yes.
It wasn't it 5 over 3 earlier and 5 over 4, so I didn't really mean to make it that way. So if y'all are okay with it, I'm not going to finish the simplification. I could, but it looks just like a slide. Right. Everyone agree?
Wait. Okay, yeah.
This is 1 plus the square root of 3.
Yeah, you don't have to do it.
And identical steps on the last one. Okay, what about this last one?
Split them up a lot.
Yeah.
Hey,
Good.
or you could put them back together and split them up better.
Or I could just put them back together.
yeah, and then you get
What is this put back together?
35 over. No.
80 plus 55?
35. Smart.
Is 135 on my unit circle?
Think so? Yes. Oh wait. Yes. It's like
Tangent of 135?
it's like negative square root of 2. I was gonna divide.
Right? Tangent of 135 is negative 1. So that one, if we just put it back together, it works out quite nice.
You have a question?
It's gonna come really dumb.
That's tough.
What are we trying to find?
We're trying to find the exact value. So, like a number answer. Well, the top one, to find a number answer, we had to break it up. But this one was the identity, and if we ended up putting it back together, we could find the tangent of 135. There is not one because we weren't given units, so I'm not sure what we were doing.
-1.
So we're just doing math with no application right now.
Oh.
Okay. Find the sine of s plus t and the tangent of s plus t and sine of s is this. Did we actually do this one?
We did something like this.
Okay, so we would like to see another one probably.
Yeah.
Yes, we will cross.
Sweet. Favorite.
Try.
My favorite shape now is understand. Well, I didn't understand. What's going on?
I play football. Someone make a sign. Well, he made fun of me for saying plus 90. And it was plus 60.
Okay.
Yeah, Pretty good.
Hey,
First time for Michael with the coffee.
okay. So let's start with the sine of s plus t. So find that, because I don't know what the angles are, right? So I sure can't add the angles together and find a new triangle. That would be very difficult and probably impossible. But what I can do is break sine of s plus t into sine of s, cosine of t, what am I using here?
Those equations.
Plus cosine of s, sine of t. Does that look right? Is that how yours is, or is yours flipped? Is it the same thing, or did I write it?
Where are you
different?
using this?
For those,
Oh, yeah.
one of the identities. So now,
I don't like to get them guys. Clearly, it's like,
okay, so S is in quadrant 1. So I'm going to draw a triangle for S in quadrant 1. Sine is 3/5, which probably lets you figure out the third side.
4.
And T is in quadrant 3. And sine is negative 12 over 13. So you want to know the other side.
5.
If you didn't know those, how would you find them?
Pythagorean theorem.
Use the second.
Alright.
So the sine of S is 3/5.
Yes.
Cosine of T is negative 5/13. I just wrote it down. I didn't say anything. Why is that 5 negative? Cosine of S is 4/5. Sine of T is negative 12 over 13. Do some multiplication. Alright, is that right? Is that right? Negative 15 minus 48 is negative 63. Is that right? Okay, any questions about that one? Now I want to find tangent of s plus t.
Yes.
Which would be tangent of s plus tangent of t.
Over 1 minus
Tangent of s is 3/4. I don't know where I'm getting all of that stuff.
Yes.
Tangent of t is negative 12 over negative 5, or you could just write 12/5.
Yes.
You do need to either get common denominators on top and bottom, or I do want to remind you of a little shortcut I taught you. I could multiply the top and bottom by 20. Why would I do that?
Because that will make it.
That would be the least common denominator, right? And if I multiply
Alright.
it would be negative, the tangent of t would be negative, but 12 was also negative. And so negative 12 over negative 5. But you could write the negative on both of them. Okay, so I'm going to show you the shortcut. If you want to get common denominators, it'll work out the same. I'm going to multiply everything on the top and everything on the bottom by 20. 3/4 times 20 is 15. I'm getting that 4s would cancel. This would be 48. 4 times 12. 36.
4 times 5 is 12.
And so if you do that, you get rid of all the fractions all at once. Or you can get common denominators. You think so too? I don't care. As long as you get right answers, I don't care. Okay. Add these together, you get 63 over negative 16.
Yes.
Any questions about that? If you wanted to find cosine, you could find it by dividing between sine and tangent.
Look at the numbers on the bottom.
This one,
Yeah, both of
so
them.
20 times 1 is 20. And then 20 times this set of fractions cancels with the 4 and the 5. And so you get just 3 times 12, which is 36. Makes it go a little faster. It's not any different. You'd get the 6 the other way. In the middle of class. I suppose next time you try to find out better. Okay.
Bye, Chris.
Write an algebraic expression for x. I don't even know if you have any in your homework this hard, but just so you know. Would you agree that this is some angle? Sine inverse is some angle? And this is some other angle?
Yes.
So I could rewrite this as cosine of sine inverse of x times cosine of tan inverse of radical 3 over 3 times. And then what goes in between? What identity am I using? Cosine of alpha minus beta or a minus b, I don't know how you're doing words in class, plus sine of sine inverse times sine of tan inverse radical 3 over 3.
Wow.
And I want an algebraic expression with just x's.
That's one of the.
Okay, good. Sine of sine inverse just cancels and you just get x there, right? So that's pretty easy. The others I'm going to have to draw some pictures. What angle would make tangent radical 3 over 3? But you actually probably even know the angle that would cause that. What angle would make tangent radical 3 over 3? Okay, it's either a 30 or a 60, right? They would be tangent opposite to be 1 and the adjacent to be radical 3, correct? Opposite over to 1 over radical 3, which would rationalize radical 3 over 3, which is not a 60. It's a what?
30. So 30, yeah, 30, guys. 30.
Hi,
Does
Chris.
everyone agree that it's a 30?
Yes. Okay, good.
Everyone agree that that is a triangle that would cause tangent to be radical 3 over 3.
What's your right explode?
What sine of sine inverse? Now, if this angle is that one, what's the sine of that angle?
That's the 1.
1 half.
Whoa!
Everybody so far? If this is that angle up there, right? This is that angle B or whatever. What is the cosine of that angle?
Third and 3 over 2.
This one I'm going to have to go draw another picture, right? Because I don't know what cosine of sine inverse of x is. But I am going to draw a picture. Sine of x, or sine inverse of x, that means it's the angle that causes sine to be x, opposite over hypotenuse. Does everyone agree? X over 1. Sine inverse being x. That's the triangle that would cause that. Gotta find the third side of that. Do a 2x. Well, let's first find the third side. And how would I find the third side?
So for sine inverse,
Well, remember this is the angle that makes sine equal x. So you have sine of some angle equals x. That's what that means. Right? So sine of angle A equals x, which is opposite over sine. Now, that's great. What's the third side? How do I find the third side of the triangle? Right.
Take square root, or not square root, the radical of 2 of the x, and subtract out the hypotenuse minus.
Pythagorean theorem, right? X squared minus 1.
Let's go through them. Let's see what's up.
Put the 2 over the 2 plus the 2.
Stop.
And the x
Square. Square. That's the word I was looking for.
Okay.
Like, where are you getting a 2 from? Here I see where you get it.
Time out. Time out. Quick question. Here it is. That 9 plus 4.
Yes.
No.
Wait.
25.
And you were to do something with it when you have to flip
Oh
it,
yeah,
right?
forgot.
It's not 3 squared plus 3 squared. So,
Can-
next question. Can you distribute the 1/2? No, you can't distribute exponents over pluses and minuses. So a square root is a 1/2 power, right? It cannot be distributed over plus or minus. The square root of 1 minus x squared is just the square root of 1 minus x squared stuff. Is this an expression just with x in it?
Yep.
Yes, so we are done. That's what the question asks us to do. Write as an algebraic expression of just x.
Or
And
you
we
can
could.
simplify it some
You could. You don't have to, but you could.
times.
This one times 3.
Do something else.
Do we want to see another?
Yes.
We already did this slide, didn't we? Did we do this one already?
No.
Yeah.
Yeah, this is the
Yeah, I know
last
that.
problem, then you'll have some more steps. Okay. So, to do this one, I'm going to have to write it as, I'm going to, for a moment, call this A and this B, right? So we're going to do tangent of angle A, right? Plus tangent of angle B over 1 minus tangent of A, tangent B. Everyone agree with all of that so far? So the cosine inverse of x is some angle, and the tangent inverse of x is some angle. So I'm going to draw those two angles. I am assuming this is positive. I don't really know that. But we're going to assume that those angles are correspond. Okay, so angle A is cosine being x, so adjacent over hypotenuse, correct? And angle B is tangent being x, so opposite over adjacent. So on angle A, this side would be the square root of 1 minus x squared. What about on this one?
That'd be 1 plus 1 plus 1.
Good. So the tangent of A would be the square root of 1 minus x squared over x. Tangent of B.
Wait, what is the tangent of tangent tan inverse? Wouldn't that just equal x? And
Probably, and let's look.
tan inverse.
Does it? Does it in fact equal x? I agree. Absolutely. So could you have done that piece without drawing a triangle? The tangent of tan inverse ends up being just x. If they have numbers in it on your homework, I want you simplifying and rationalizing and all of that fun stuff. On these, I don't care.
over.
Oh, right.
Right? So you would agree that, what are we doing, this one right here? Was it tangent? Not that it matters. Okay, this one. So the sine of 90 minus theta equals cosine of theta, right? So, couldn't I just do 90 minus theta? Okay. Doesn't matter what the angle is, positive, negative. We're just going to do 90 minus tan angle, right? That's the formula. I think y'all might have needed to see that so you don't overthink it.
Which is 4 pi over 6.
So we'll do pi over 2 minus 7 pi over 6. I do need to get a common denominator. This would be 12 pi over 6.
Can't you just change one to the first one to 3 pi over 6?
Oh, sorry.